All right, so where do we leave off? Well, we left off at this thing called a confidence interval. And we described what a confidence interval really was. Okay, so imagine yourself getting ready on a Friday or Saturday night because you're going to go out on the town. You're going to go to a restaurant, you're going to go to a bar. You buy that nice new dress, or you buy that nice new shirt. You put it on and you feel good. You go out on the town, you're confident about yourself, right? Well, then you have a couple of drinks in you while you're out, and you feel even more confident about yourself at that time. Well, that's a different story. But it's kind of the same thing here. We, in a laboratory, can produce a number, and we feel a certain confidence about that number. How confident are we about the number that we are reporting? Okay, so for instance, if I give you a value, and let's say that value was 1.5, that's the result. What's the unit? Who cares? It doesn't matter. Let's just focus on the number. 1.5. Here's your sign. Well, I have a certain confidence about that number. Do I feel really good about that number, or do I not really feel good about that number and maybe just kind of hide in the corner and hope and cross my fingers that it's actually true? That's where confidence interval comes in. Sometimes I feel good. Sometimes I feel really good about the number. And sometimes I wouldn't even want to bet on myself with the number that I'm reporting. That's the confidence interval. Okay, so just like you out on the town, you know, new clothes, you got a certain swag. A couple of drinks in you, you swag a little bit more. We do the same thing in the laboratory. And that's where we get the different intervals of confidence. So in the table that I'm getting ready to show you, you're going to see a couple of different columns. One of them could be maybe a 90% confidence interval. That means you are 90% certain about the value of the number that you're reporting. You feel good 90% of the time. 10% of the time out there, you could be wrong. But 90% certain that you are spot on to that number. Well, there's a 90%, there's a 92%, a 93%, there's a 95% in here, there's a 99% in here. They come in different forms, they come in different percentages. So 99% confidence interval means you are 99% sure that you are reporting the correct number. There's a 1% chance that you're wrong. That's how you need to interpret the intervals. 95% confidence interval. You're 95% sure about the number. There's a 5% chance that you're wrong. 90%, there's a 10% chance that you are wrong. Okay, so as you can see, the higher the confidence interval, the more trustworthy the number's going to be. But there's a drawback here, because there's got to be something that's happening to the numbers. If I feel better and better and better about them, what is going on? Well, like we said before in the previous video, interval means a window. So this could be my result, 1.5. But the confidence interval is going to provide a window for me that I report. Okay, that window is 1.5 plus or minus something. That is the window that we are getting ready to refer to, because this has a direct connection with how good I feel with the numbers. Alright, so 1.5 is the value that I've reported. Confidence interval. I do the confidence interval calculation. You've not really seen that yet. That's to come. But I do that calculation and I get a window, a range. And let's say that that range is 1.5 plus or minus 1. We'll keep it easy. And let's say that this is my 90% confidence interval calculation, right? We're just kind of making numbers up here just to do an example to kind of look at the theory or look at the concept. So if I do a 90% confidence interval, 1.5 is my value, plus or minus 1. That's my confidence interval. What that means is that 1.5 minus 1 is a half, and 1.5 plus 1 is 2.5. So this is my window. So what I'm saying here is that I got a 1.5 value, but I am 90% certain that the true value, it's not 1.5, but it's the true value, lies within the window of a half to 2.5. So if I went to Vegas and I put my money on the betting table, 90% confident that the true value, whatever that value is, that true value lies within that window. And that window is what we call the confidence interval. All right, well, that's at 90%. Well, let's say that a company doesn't really like that. 90%? There's a 10% chance that that number's not going to fall between a half and 2.5. That's not good enough for us. We want to expand the window a little bit. We want to feel better about the number that we're reporting to a customer. So hence, we get all of these numbers and different confidence intervals that can come into play. So if I go to a 95% confidence interval, what happens? Well, I feel better about my number. 95% confident. That means there's a 5% chance that I'm going to get the answer wrong. So if I was at a Vegas betting table, well, I would feel better about my bet, because there's only a 5% chance now that it's not going to win, versus the alternate route that we talked about just now. 10% chance of it being a loser, big fat loser, right for you. Okay, so what happens? If I feel better about my number and there's only a 5% chance of me getting it wrong, what happens when I do these different confidence intervals? Well, my result's still the same. I still report my result, my finding, whatever I get. 1.5, here you go, this is what I got in the lab. The confidence interval, though, the window becomes bigger. So if I plot these numbers into the calculation for confidence interval, what I see is that my confidence interval maybe could creep up a little bit. And instead of a plus or minus 1, I'll get a plus or minus 1.5. Larger number, larger window. So 1.5 minus 1.5 is a 0, and 1.5 plus 1.5 is a 3. So this is why you feel better about the number, because you're reporting a value. That value gets submitted to a company, and in this case, you're 95% certain that the number falls within this window. And what you've done is that you've made your window bigger. Bigger the window, the more chances of the actual number falling within it. That means the 99% confidence interval would have even a larger window than 1.5. A 75% confidence interval, you're 75% certain that the number is actually true. That means there's a chance, 25% chance of you getting that number wrong. Well, what do you think is going to happen to the window there? The window is going to be very narrow, very short. It's not going to be a 1 in case of the 90% confidence interval. It's going to be much, much smaller, maybe a 0.25 or a 0.2. But again, all of these are just examples. They're just analogies, so that way we can kind of comprehend what this confidence interval is all about. But that is what confidence interval is. How confident are you on the results that you are submitting? We know that our actual result, 1.5, is not accurate. We know that. We know this concept of error now. We know that every single thing that we do is not perfect. We know there's errors in our transfer, there's errors in our measurements, there's errors in our glassware, there's errors in the solution prep, there's errors in the equipment, there's errors in the calculation, there's errors in the rounding. Errors are everywhere, and I know that when I report a 1.5, that is not a true number. The purpose of the confidence interval is to go in and give us a window. And this window, whatever the front and back values are, the true value is going to lie in that window somewhere. Bigger the window, the more chances of the true value to fall in it, which means I feel better about my number, which means that I have a higher confidence interval as far as the calculation goes. All right, so in Blackboard, what you're going to see here is a document. And this document is going to be about 30 pages long, believe it or not. And in that document, you are going to see a table that looks like this right here. This is a very important table for you to keep a lookout for. I would probably print this page only. Don't print the entire 30-some pages of wording. You don't need it. But print at least this one page, because you're going to refer to this confidence interval all the time in the world with statistics. So print it off, cut out that table at the top, put it in front of your notebook, put it somewhere that's easily accessible, because you're constantly are going to have to refer to this table over and over and over. Okay, so let's look at how to interpret the table for a minute. Up here at the top, table 4.2 says values of students T. Okay, well, what's a student T? Okay, well, we'll talk about that in a minute when we look at the confidence interval equation. But notice that there's multiple columns for confidence level or confidence interval. It goes by the same terminology. CL for confidence level, CI for confidence interval. Either one of those are okay. And there's a couple of different choices here. This is not the full table by all means. It's a shorthanded table for you. But there's a 50% confidence interval. I'm 50% certain that the number's going to be in that window. There's a 50% chance that I'm wrong, though. I don't want to take you to Vegas and bet money on you. And then there's a 90% and a 95% and a 98 and a 99 and a 99.5 and a 99.9. And there's all these numbers that are down below each column, but this is the first step of interpreting the table. You've got to figure out how confident do you want to be when you report these numbers. There is a default. The default is the 95%. So if the question doesn't tell you what confidence interval to pick, you automatically go to the 95% confidence level. Ignore all the rest. Sometimes the questions are very specific and it will tell you what confidence interval to pick from. But if it doesn't, keep in mind you go to the 95 every single time. I can't stress that enough. All right? So the degrees of freedom, what are these numbers? Where do they go? What's this thing called a student T? That we'll talk about in the next video when we look at the actual equation that we use to calculate the interval that we need to report with these numbers. So stay tuned, we're not done. Keep this table handy though. We're playing Blue's Clues.